Hello, you absolute legends. There are four primary intermolecular forces, and when analyzing molecules, we start with the strongest and work our way down until we find a match. In a previous video, we discussed how to identify if an ionic bond or a salt bridge can occur. If the molecule cannot form a salt bridge or ionic molecule, then you consider next in line if a hydrogen bond can occur. A hydrogen bond is in some ways the easiest to identify because there's pretty specific conditions for it to be possible. The first condition is that hydrogen has to be present, not a surprise. That hydrogen present has to be bound to an oxygen, or has to be bound to a nitrogen, or has to be bound to a fluorine. So if that molecule contains a hydrogen atom and it's bound to one of these three, then a hydrogen bond is possible. The other thing that has to be present are lone pairs of electrons. The lone pairs of electrons are the negative source, and the hydrogen bound to the atom with the high electronegativity is a positive force right there. An example of a molecule that can perform hydrogen bonding is ethanol. Now, starting with our ranking, ethanol cannot form an ionic bond because it doesn't have a positive and a negative end there. It is a neutral molecule overall. Now, next question is, can ethanol form a hydrogen bond? It has a hydrogen present, and I actually don't have all the hydrogens present on this molecule. There are hydrogens bound to these carbons. And it does have a hydrogen bound to an oxygen atom. So check. So it passes part A. And it also has lone pairs on an oxygen atom. The lone pairs could be anywhere in the molecule. Just as long as it has these two criteria, it can form a positive, negative hydrogen bond. So this ethanol molecule here has a negative N, or a negative face, with those lone pair of electrons, and it also has a positive face because of the hydrogen being bound to the highly electronegative atom, in this case, oxygen. So when another ethanol molecule in solution shows up, it has a negative face, like this lone pair of electrons, and it has a positive face, like that hydrogen atom. So this molecule in solution will arrange itself so the positive and negative ends are facing each other, forming a hydrogen bond, which is second in our ranking of strength. We would stop the analysis there and wouldn't go on to dipole-dipole because we found a match. I hope this helps. Thank you.